So inheritance gets very complicated, but the first step is to understand simple or linear inheritance. So what does inheritance do? Well, let's first start with a reminder. So we had seen how to define a class in Python. So there was a keyword class, and then there was some docstring, the name of the class, and then some other class that might be specified here, or maybe object would be written here. Then some constructor method, and then different methods that were used to define the class, that were associated to the class. The point of inheritance is this part. We're making my class here inherit from the class another class. So let's see an example. We have here a class A that inherits from object, and every class should always inherit from object either directly or indirectly. How do you inherit indirectly? Well, that's what class B does. B inherits from A, which itself inherits from object. So I defined some other methods, but among them, I have first method for A and second method for B. Now, you should always think of inheritance as saying B is A, or an instance of B is an instance of A. So that means that whenever you have an instance of B, you're allowed to call any method that is allowed for an instance of A. This is called the Liskov substitution principle. So it's very important in object-oriented programming that if you subclass, so if you have B inherit from A, anytime you have A used somewhere, you could substitute B for it. The converse would not be true. So it would not be true that whenever you use an instance of B, you could use an instance of A instead. B is more specialized than A, which means that B could be substituted for any occurrence of A. In particular, what happens is whenever you have an instance like little b here of big B, then B has access to second method, so that's not surprising because second method is defined in the definition of B, but also to first method because B is also an instance of A. Okay, and A had a first method. So that's the main idea of inheritance. The idea is that you make one class dependent on another, and that first class gets all the method that the other one had. So in this case, B acquires the methods that A had. This immediately leads to another concept, which is called method overloading. So in this case, A inherits from object, and I'll start drawing arrows for this. So A inherits from object, and B inherits from A, and C inherits from A as well, but not from B. Now, A has a first method, B has second method, so we just saw that instances of B have access to second method and first method. That's not surprising. But C redefines, well, C has a third method, but also gives a method definition for something called first method as well. So this first method occurs here, but it also occurs there. So the consequence is that whenever we have an instance little c of big C, this little c, we can call on it, we can call first method, second method, this was a 1, sorry. So we can call on it first method and we can call on it third method. But if we do c.first method, then the one that gets called is this one, not this one. Okay, so this method here overloads that method there. So how does it work for Python? How does it do it? Well, as I was drawing, it has this mental picture of C inherits from A, which inherits from object. And whenever you do you define an instance first of big C. Whenever you do little c dot sum method, what Python will do is that it will look whether some method is defined in the class definition for C, and if that's not the case, it will go up one step and see whether some method is defined in the class definition of A, and then it will go one step up and see whether some method is defined in the class definition for object, which doesn't really exist because object is a built-in, but it will see if some method makes sense for object. So this leads to the concept of duck typing. And the idea with duck typing is that it's usually said if it behaves like a duck, then it is a duck. So what you're checking is only whether the methods exist and not really checking on the types. So if some method exists and some method leads you to believe that you have a duck, then for all practical purposes, it's really a duck. So this means that you only check whether the method exists and not really whether C is really an instance of big C or an instance of big A or an instance of object. Okay, so this is the very simple introduction to linear inheritance. It's called linear inheritance because so far we've only seen the case where this whole superclass graph from C is linear. There's only a linear dependency, but we'll see that this can become quite more complex.